And we're live. So, hi guys, my name is Jan and I'm part of DoraHacks. And welcome to our second workshop session of the Archway Hunt-A-Thon. And before we start, let me give you a bit of background of this hackathon. As the largest Web3 developer incentive platform, it's an honor for DoraHacks to support the Archway Hunt-A-Thon. And we're looking forward to seeing a lot of incredible projects building on top of Archway. And today we're happy to have Rafael here, Head of Business Development at Nomos. And so without further ado, let's welcome Rafael to start. And for the audience, if you do have any questions during the session, feel free to drop them in the comment section. At the end, we can do a Q&A. And if you haven't subscribed to our channels, please do so, because there's a lot of other cool workshops happening in the next few days and weeks. So feel free to start once you're ready.
Hello, everyone. Thanks. Yeah, I'm Rafael, Head of Development at Nomos, and well, I'm going to explain our latest product, which is Nomos V2. It's basically, we also branded as super accounts. So without further delay, let's start with the documentation. So you can see the documentation on our website, nomos.ms. Once you click it, you go to the version 2. I'm going to give you a brief introduction about all of this, about all the sections on the documentation and everything you can do with our systems. First, what is the super accounts in Nomos? Super accounts are basically multisigs, what you know by, as shared accounts with a smart contract. This multisig has many features that are introduced thanks to the CW3, CW4 standard and in the Cosmos space, in the CosWasm space. But it also introduces a new concept that we've been building with smart contracts, which are interchain accounts. Interchain accounts are basically accounts that are controlled from a source chain to a target chain. It's very flexible, interesting, and it allows you to do so many things, such as paying gas in a certain token from the source chain to make an operation to the target chain. So that's like an overview of super accounts, a multisig with multiple functionalities and an interchain functionality enabled by ICA. So to get started for this hackathon, we created this small repository, Archway Hackathon. I'll be sharing the link later. Currently, we don't give access to the main repository with the smart contracts, but you can still interact with them, and we already deployed them on a test on Constantine from Archway, so that you can interact with them. Okay, let's go to features so that you can know what you can do with this multisigs. First, let me introduce you what is CW3 Flats. For those that you already know, great. For those who don't, CW3 Flats is basically a multisig, but which is very flexible. Not only modular in the sense of the code being modular, but also flexible in the sense that you can add and modify the member set of the multisig in many ways. There are 3 contracts on CW3 Flats. First, the wallet contract, second, the voting module, and third, the membership module. The wallet contract, what it does is basically having the wallet contract basically what it does is just being a wallet. Like when you talk about the address of your multisig, you're talking about the address of the wallet contract. This is the one responsible for sending transactions to the blockchain. The other contract is the voting module. This module is, the one that holds all the logic that we know about the multisig. This is where the members vote and propose new transactions, new actions inside the multisig. And the member contract, its only responsibility is just like holding the members. You can hold the members statically and never update them. You can hold the members and update them, or you can even do crazy stuff such as, okay, the members of this multisig will be everyone who holds this token, everyone who holds this NFT, or everyone who has a liquidity position in certain pool. So it's very interesting, the things that you can do with these 3 sets of contracts. You can also modify the the voting module and update and upload your own voting module. And a multisig can have more than one voting module for different voting settings. That's all about the modularity. Now, about interchain accounts, I won't in this workshop, I won't explain much about this. I won't make examples about this because I want to leave all the things related to interchain and some other advanced features such as meta transactions to the next workshop. If we have some time on this one, I'll explain a little bit about meta transactions, but for now, this is for later. You can also enable sub-server accounts. This is pretty straightforward. It's basically having, you can enable it in two ways, like having one multisig being a member with high weight in another multisig, or just setting the executor. I'm going to explain what is the executor later. But if another multisig is the executor, then it will be the last word for the source multisig to be able to send a transaction. Here is the section for supported networks. As I said, we support networks on Constantine, and you can see the 3 contracts I explained before right here. Now about the structure, I already explained the structure. The contract components, you can find it here, and you can find some more specific documentation about each contract here. We have a factory, by the way, because setting up all the contracts, like creating a multisig, is complicated. I mean, the wallet is admin of all the contracts, so that the multisig is only be able to be updated by itself, by its own proposals. And the other contracts have also some configuration to interact between each other. Let's go here to the factory. Most of the operations that you're going to make when working with our SDK in JavaScript are going to be towards the factory or towards the vote module. Why? Because the wallet contract owns itself, so you can't really make anything with it unless you make a custom implementation where you change everything. But yeah, the wallet contract owns itself, so it only can be called, like the configuration functions related to the wallet can only be called using the multisig itself. So you need to, for example, if you want to change the admins of the multisig, which currently the admins are only the voting module, you need to create a proposal to update it. Let's go back to the factory. Here's the instantiate message. Here you can see an overview of all the messages that you can do with the factory. Update factory contracts, claim ownership. Most of them are only owner. So only if you're the owner of the factory, you can modify it. If you want to create your own factory, you can. We share, like here in the supported networks, we share the factory code ID if you want to create your own with your custom modifications. Okay, here initialization, you can, here is in the SDK section. This is what you're probably going to use the most. It's only like you need to install this package, which is Nomos v2 with npm, yarn, whatever you need. And then after that, you're going to do this operation, like copy all this code, initialize you signing Nomos client, your signing comes wasm client, and then pass the signer address and the factory contract address. We also share the factory contract address in the network section. After that, the factory has, you can see all the methods here, the query methods and the transaction methods. I'm going to go first with the transaction because the query are very straightforward, very simple. The create multisig method is the main entry point for a protocol. Here you configure everything from the ICA account, interchain account, to the multisig settings, voting, proposals, etc. The other methods are only owner, so you really won't be using it unless you create your own factory. So for usage, here's a small example, or medium example of how to create a multisig. Now, each of these parameters has its own purpose. For when creating a multisig, you will always create an ICA account, an interchain account. So you need to be really careful with this, because if this is not configured properly, the channel opening init options, then the multisig won't be created. The transaction will fail. The connection ID is the connection that you want to, when you, for those that are familiar with the ABC protocol, you already know what is this and what is this. But when you want to create for those who don't, when you want to create an ICA account, interchain account, you need the connection between those two chains. So there are two connection IDs: the source connection from the chain that the multisig will be created, which is in this case Archway, and the target connection, which is the other chain that you want to create, where you want to create the ICA account, for example, Osmosis. So both of those connections have a connection ID. You must put the source one here and the target one here. Now, for instantiate multisig message, I'll explain each one of these later in the vote section, but keep in mind that this is basically all the configuration you need for a multisig. Now, for salt, this is also an important field. In our factory, we use instantiate2 rule function in Cosmos. Instantiate2 is very similar what in EVM is create2, and it creates contracts deterministically, giving a salt and the contract that is creating the other contract. So this salt, for example, if you're going to create multiple multisigs, this salt needs to be different for each one of them. So try to use a very random number or very random string here when creating it. It can be anything. It can be text. As long as it is a string, it's okay. Now let's go to the vote module, because as I said, the rest of the modules are not, you won't be able to modify them unless you create your, you won't be able to modify the rest of the modules, but you can check if you want the messages that are available for each one. The vote module is the only one where only members can interact with the multisig. The instantiation settings are the same as the ones that you saw before here. Instantiate multisig message is the same as all the arguments in the vote module on the instantiation. So let's go to each one of them. Give me a second. Okay. Let's go to each one of them briefly. The threshold. The threshold can take many values. Those values determine how the multisig decides that a proposal is finished. For example, you can set the threshold as a percentage of all the members in the multisig, a fixed weight from the multisig, because each member has a weight. Those are the two main ones. There's a third one. You can find it in the SDK definitions. But yeah, those are the most important ones, and the ones that you will probably use most of the time. There's also a match voting period. Match voting period is, well, its name sets it itself. Is basically the period of time that a vote will take, a proposal will take before being ditched. So if this time is passed and the proposal hasn't been voted, then it won't be executed. The executor is the field that I mentioned before. If you set the executor as none, then anyone can execute a proposal. If you set it as an address, then only that address will be able to execute them. So you can make what we explained before, sub-multisigs, because one multisig can be executor of another one, and if that second multisig approves a proposal, then the first one needs to send a message to that one, to the first multisig, to be able to execute the proposal. We also have proposal deposit. You can configure the multisig so that each time someone creates a proposal, they need to deposit it. They need to deposit some tokens. You also have group address. Group address is something that you won't find in the factory configuration, because we create it. Like we instantiate the membership contract, which is the group address, and we feed it to the vote module. The wallet address also is the same. The factory takes care of it. The sender, this is not used currently. Like it doesn't do anything in the multisig, so you really don't need to use it. Revoting, as it says, allows a member to vote more than once in a proposal. Automatic execution should not be used along with executor, because automatic execution will make a proposal executable in the moment it is the voting passes, the voting goes through. So if you set this as true and you have an executor, the executor won't do anything, because the proposal will be executed with the last member that votes positively. Open proposal submissions. This allows only members or anyone to submit proposals, and open proposal deposits is used along this one to make external people to propose, but also to deposit in the multisig. So yeah, these are the execute messages. You can find the definitions in Rust here if you want to integrate with Rust, or you can use the SDK below. Now on the SDK, on the SDK you have the query methods that basically, query anything you want from the contract. I won't go deeper on this one because of time, but you can find the definitions on what they do here and in the SDK. Transactions methods. Okay, this one works to propose a transaction. You set a title, a description, and the messages. The messages are just custom WASM messages, like for example, bank transfer, WASM execute contract, WASM instantiate, etc. Vote just votes over proposals. Once you propose, there will be an event triggered that will send you the proposal ID. You need that ID to vote in a proposal. Vote with signature. This one is very interesting. You can sign a message, and we have the example like here. You can sign a message with the vote that you want to make, and someone else can send that message to the contract to make the vote. This allows, for example, if someone wants to sponsor voting in a multisig, they can do it with this. Users will only have to sign messages with anything else, and the sponsor can just send this and sponsor the gas for the users with the signature of the user. The execute is something that only the executor will use if there is an executor, or anyone can call this if the proposal is not finished on execution with the configuration I explained before. The closes a proposal that hasn't been executed or expired or anything. Member change hook, you won't need this. It doesn't do anything currently because, you can only use this if you modify the contracts. If you modify the contracts, and we'll release them later or not during this hackathon certainly, but if you modify this, you will be able to receive a change. A call each time the membership contract is updated. But as I said, only if the contracts are released, and that won't happen in this hackathon. Update threshold. What it does is what its name says. It updates the threshold of the multisig. It can only be called by the wallet contract, so this can only be called during a proposal. Same with update settings. It updates the settings of the multisig. Here is a small usage example. As you can see, I left the message empty because you can put any message here, a transaction or a bank message, a staking message, etc. You need to put the signer address and the voting module address. How do you get the voting module address? Well, you need to, when you deploy the multisig with the factory, the SDK will return events, and one of the events will be an instantiate event with the code ID of the vote module here. What else? The outs proxy. This won't be used in this hackathon, but stay tuned. It's very interesting. Now let's go to the examples that I left you here in the GitHub. So here are all the examples. This repository is very useful. Like it allows you to even write scripts easily. For example, and create multisig, you won't need to worry about the client nor anything else. Everything is set up by the repository configuration. You only need to put your env variable, your env variable with your mnemonic, and everything will be done here. If you want to modify the configuration, it's also here, the config and index. Now let's go to our terminal to make the example work. Okay. So this is the example. The way it works is very simple. It works with npm, with nodes. So you only need to run this script. Yarn start. Then there's a command called action, and action will be any of these proposals. For example, create multisig should be like this, and then you can specify other things, like, for example, wait a second. Okay. You can also specify other arguments, such as a contract. The contract is the factory on this script, on the create multisig script. So you go here, networks, you pick the factory, and you put it there. You can also specify the chain. The chain configuration, the chain names is here. So you can see Archway mainnet, Archway testnet. So in this case, it's Archway testnet. And then after that, that's it. I'm going to modify the salt, because the salt requires me, I already used the salt. That's what I mean. So I need to modify it to be different. And I'm also going to add another member, which will be, I don't know, like a contract. It can be anything, because I want that other member to avoid executing messages. Because let's do it like this. Because what will happen if you don't add this member or any member is that when I won't be able to vote, because once you create a proposal, you need to vote, and I want to show you how to vote on this proposal. So let me think how I can do it easily. Let's do it without it better, because I won't have time to show you to change accounts here. So let's run it and see what happens. You only need to wait, and it should show you. Okay, not possible to reach the required passing weight. Okay, this error means that in the configuration of the multisig, the weight, the absolute count, was higher than the members. So you always need to put it in lower or equal than the member count. And that's it. There's a transaction. Now let's open Archway min scan, so that you can see the transaction and you can get the information that you need for the voting, the wallet, etc. So as I said, when you create a multisig, you will have many events of instantiation. You will have 4 events of instantiation, because we create 4 contracts. And one of those contracts will be the voting module. That is the one that you will interact the most. The 4th one, here it is. So let's go to networks, and let's get the wallet mod. Oh, but I changed it. I need to update it there, but yeah, it's this one. It's not exactly the same as this because I need to update that section of the factory. But well, let me pick the address. So once this is executed, like I'll have already the multisig. So let's pick the multisig. This is the wallet. Wait again. What it says. And this is the multisig. This is where you should send funds if you want or an NFT or anything into the wallet contract. Now let's create a proposal with this one. Let's go to create proposal. You can modify all of this if you need, or you can create your. This is only as an example for you to make it easy to interact with the Nomos SDK, Nomos V2. So this proposal only creates only sends funds to an account, to my account, but this is what will happen. Like when you create a multisig, right? You have a threshold. That threshold is 100, and I as member have 100, and the automatic execution is true. So what will happen here is that this won't be executed unless the multisig has funds. So always when you make a transaction that will take funds, send it to anywhere, you need to send the funds first to the multisig. So let's send some cons to our wallet. The wallet contract. Need to change tabs. So send. We wait, and that's it. Then we go back here and we can create the proposal. Let's modify this, create proposal. Let's modify the contract with which we will interact, which is the voting module. This one. The voting module is actually 24 to 64. Need to update it in the documentation because we updated it last time. After create the proposal, you can check the required arguments here, contract, and that's it. It should work. Then if we pick the transaction and go to MISCAN again, let's open another one. You'll see that the proposal was executed. Event logs, message, execute, coin spend. This is the one that is interesting for us. As you can see, we spent 1 const and my account received 1 A const, the smallest amount. So that's it for this example. I won't be going over the other ones of vote proposal and signature. Only will explain the script because I need another account and I haven't set up another account. So on the voting proposal, if you go here, first you need to set up the contract, which will be the voting module. Then you will set up the proposal, which is the proposal ID. It's a number. It grows over time. So the first proposal is 1, the second 2, and the third 3. Each time you create a proposal, on the events, it's returned. You can see on the events here also the proposal ID that was created. So you can also on the votes that you can make, you can only make yes, no, abstain, or veto. Veto is to cancel the proposal immediately. But of course, it's all the members need to vote veto, or at least the minimum threshold of members. Now, on the voting client, you initialize the voting client. As you can see here, it's already initialized. Then on the vote side, you only do this, like call the vote function with the proposal ID and the vote. As I said, you can see the vote types also in this example, and you can see more information about the functions available on the types that it receives here in the SDK, the TypeScript definitions. Now, another one that is pretty interesting, and it was a little bit hard to make, is the voting with signature. This one is pretty cool, and I'll be going over this one more in depth so that you don't make the mistakes that we did while building this. So first, we generate the signature. The signer, the member of the multisig, must do this. With his private key, he must sign a message that will be sent to the contract. So as you can see, he passed the signer and the chain ID and the vote that we're going to make. The vote contains the yes, no, maybe, etc. And the proposal contains the proposal ID, and the contract contains the address of the voting contract, of the voting module. So you create an amino message. You can find the types in custom.js amino. You won't fill the type because our contracts don't need a type for the message, and you fill the value, which is a vote. And after creating the amino message, you're going to use this function called make sync doc. This function you can find in custom.js amino, and it will receive a series of messages that you can define here. Currently, we only support a single vote for each signature. So you can only put a single message here. Then for amount, you can specify also amount and gas, but we don't use it, so you can be empty. Or you can put anything here, and it will still work, like 1, 2, 3. You also need to put the chain ID. This is really important. If the chain ID is incorrect, then it won't work. The signature will throw an error, and you'll know because the error says wrong chain. This field is empty, and the rest fields of the fields we are not using them, so they don't matter right now. After getting the sign doc, you will use the signer. It needs to be an amino signer, and call the function sign amino. And that function will take the current signer and the sign doc, and it will return signature and signed. Now, after doing that, you will have these two objects, signature and signed. These two are very important. They allow the contract to know what you're trying to do. For example, here is the method vote with signature. You will send a signature object, which will contain the public key. For those who are familiar how the public key works in Cosmos, great. For those who don't, the public key is, it's a set of bytes, let's say. And those bytes are hashed and then transformed to create your address. You can get your address from get your public key from the address, but you can get your address from the public key. Our contract needs your public key for verification of the signature. So you need to send the public key and our contract to compare your public key with the member list. It will generate your address with your public key. The signature object that you generated before will contain the public key as like this. Now you must also send the signed doc, the one signed, exactly the same. If any field here is modified, the signature won't work, because that's how that's the point of signatures, that the data is not corrupted when sending, and it has not been tampered with. On the signature section, you need to send the signature. The signature is just a string. Of course, you must not also modify it. Like each one of these fields must be as it is, as they are presented here. Now, when this function fails, it fails when the signature is invalid. It means that the signature was not created by the signer. It fails when the chain ID is incorrect, to avoid the double signature attack, like sending, for example, a user signs a message in one chain. You can't use that message in another chain. That's the purpose of that. It also fails if the contract is incorrect. As you can see in the message, we fill the value contract here in vote, and we compare that the vote contract that you are sending message is the same vote contract that you're signing into. It also fails if the signer is not a member of the multisig, of course. And as I said, anyone can send this transaction as long as the signature, the sign, and the public key are from a member and sign it correctly. Well, that's it for today. Thank you.
Thanks a lot for the presentation. I think it was quite insightful and the audience has learned a lot. Let's give the audience some time to digest all the content you presented. And there's one question about, like, can I execute multiple messages in a proposal?
Yes, of course.
Maybe you would also want to demonstrate or show how it works, or if not, that's also okay.
Sure. Yeah, I'll do it. Okay, here let's, as I showed you before, here's one proposal, right? A bank send message. So we have this message. It's an array, so you can send multiple ones of different types also. And let's say I don't have any other type of message right now, like that I can work on. Let's maybe send. Let's go to definitions to get creative and find another kind of message to send. Custom no, taken neither, target, IBC, wasn't. Maybe wasn't. We could also create a multisig, like another multisig from here, but a little complicated. Let's just go to another bank message with a barn. We can go with a barn. Yeah. Let's send tokens and barn tokens at the same time. Barn amount. The amount is an array, so okay. So yeah, on this proposal, what we'll do is first send tokens to my account, just one account, a const, and then burn one a const. As you know, this multisig already has enough tokens. Let me see. Here is create proposal. Because this multisig already has tokens, so we're going to use the same one for create proposal. There is a transaction, and as I said, when you vote, when you create a proposal, you vote at the same time, because well, you're the creator, you're pro this proposal, so you already vote. If you enable double voting, it's okay, like you can vote again. But in this case, the multisig already has the feature of the configuration of executing the proposals in the moment they go through. And since I'm the only member and I voted, it went through. So this transaction contains the sending and the burning at the same time. Let's go for it. So let's event logs. And there is coin spent, coin received, coin spent. I think the burn is that one. Yeah. Here it is, the burn. Here we burn. The burner is the how do you say, the wallet address? No, sorry, I don't know which one is this one. But well, the burner is the wallet address. And as you can see, I received one account. This is my account. So that's it.
Yeah, that's super cool. Thanks a lot for demonstrating that. There is another question. Do I need to create an ICA account in order to create a multisig, or can a regular account be used?
Yes. Well, of course, this hackathon also helps us to know what's mostly needed. We still need to create the front end and everything for normal users to test the product. But that's something that we've been thinking too. Like, okay, should you be Like, should you create always an ICA account with a multisig? That's why we call it super accounts, like the combination of those two. So currently is obligatory. In the future might be like optional. If you want to create your multisig without an ICA account, that's okay. But currently, as I said, like on the multisig creation, you must always put these two fields. Also, for this hackathon, on the example repository that I sent you, it must have you already have the configuration for Archway to Osmosis. Archway testnet to Osmosis testnet, actually. Yeah, you can see it here, for example. Constantine to Osmosis testnet, 81.14.27. 81.14.27. So if you want to experiment with the ICA accounts, you already have the configuration here to Osmosis. If you don't want that, you can leave this like this. The ICA won't affect your multisig. Like the ICA doesn't control the multisig. Yeah, that's the word. It's the opposite. The multisig controls the ICA account. So yeah, you shouldn't have issues. In future workshops, in the next one for Nomos, I'll explain what is more about this and more about what ICA accounts are, how they work, and the ICA controller, which is something that we use to control ICA accounts.
Okay, and then there's one last question. Also, can a smart contract create and manage a multisig?
Yes, of course. Well, let's make a little experiment. Let's create a multisig that creates another multisig. Let's just copy factory, create a multisig. Yeah, let's just copy not this, but this. Okay, create a multisig. Here, all of this. Okay. Yeah, I think we can do it with this, only with this. Oh no, I have a better idea. Yeah, to show you how to create a multisig from a multisig. Let's go to factory. And let's search for, here it is, create multisig. Let's use this message. Of course, it's had some fields, instantiate multisig message. Okay, and channel opening need options. Okay, so let's create another example. Multisig from multisig. You also need to import it here. Let's copy all of this, or on create proposal. Yeah, let's copy all, create proposal. Let's go here. We will create a proposal that will send two transactions. The first one that it was already there, and the second one, which will be a wasn't transaction. And execute. And then to address. I think it was to address now. Yeah, let's just copy all of this. Contract address was the name. Let's put the factory address there. Here. The funds, 0 funds, because on creation we don't need anything. And this is the important part, the message. I'm going to leave it like this for now, but we need to put it here. Oh, sorry. This is how you create for some that don't know how to encode correctly a message towards a contract. Now here on this JSON, on this object, we will put the creation message of a multisig. This one. So we'll copy it here, and we'll fill each one of the fields. Like instantiate multisig message must have all of this. We'll fix it in a second. Now members for now, let's put it empty. Threshold. Let's go to the threshold of the factory so that you can see it. Let's pick the same exact threshold. I'm not taking it from here. It will be faster, maybe. Yeah, let's take it from here. Doesn't matter. Let's try taking it from here, because yeah, this is the usual way I do it, but it doesn't matter. Okay, faster. But the thing is that this format is incorrect, because we interact this way. We're interacting directly to the contract without our SDK. Our SDK accepts camel case like this, but the contracts, when interacting directly, you must use snake case. So we'll transform this, and we'll delete this one. And for everyone, we must do this: instantiate multisig message. Is that correct? Instantiate multisig message and opening options. Okay, correct. Also, we must use this stuff. Create a multisig message. Create multisig. That way we are almost finished. Okay, all good. Let's change the salt. Important. Some great salt. And send it to see what happens. Oh, the message. Okay. Let's test it out to see what happens. This is msig to msig, but we'll treat it as a. Let's do it here and this, because I have the script here. Okay, cool. Create proposal, right? Create proposal was the original one, so we will only change the name, which is msig to msig. Okay, it might throw an error because, I mean, too many stuff moving on and something may break. Oh, it worked out the first time. That's right.
Wow, incredible.
Yeah. It's a long stuff. Like, this message is big. Now, to show you, we should have many instantiations there. 4 instantiations on this message. And there they are here. Look at this. Instantiate. 4 instantiations. Third one. And the last one should be somewhere here. Okay, here it is. So the first one is the wallet. The second one is because this is the order, like the order that we take it. Wallet, membership. This is the ICA, if I'm not mistaken, the ICA controller, and this is the voting module. So that's it. Now, since you can also do some stuff like, for example, if you want a member to be the multisig, you go to the message, right? And it's here, the members, it's myself, but I could also have added my multisig. And my multisig would be this one. No, sorry, this one, not the previous one. Well, the previous one that I created, I could have had it here, and it will be like this multisig, a member, and the creator at the same time.
Okay. Well done. Let's go to the last question. I'm gonna display it in here, but what would be the configuration if I want to have 5 members controlling a multisig, but requiring at least 3 yes votes for a proposal to be passed?
Yeah,
Maybe
you have many
show the configuration of it, like 3 out of 5 multisig.
3 out of 5 multisig, gotcha. There are many ways to do it. First, there are many ways, like, but I show you the simplest one. Yeah. Let's go to create multisig. The only field you will need to modify is members and threshold to achieve what you want. As I said, I don't have like many addresses right now, so our multisig won't allow you to do this. You can't set up like, for example, if I create this, I don't remember exactly, but it will throw an error, or because I don't remember exactly what it does, or it will ditch them. So if you have repeated addresses here, the multisig at the end of the day will have only unique addresses. Important. But for this like example, I will only show you this. I won't run the command. This will be like, for example, oh no, let's run the command, but let's use some dummy addresses, like anyone. For example, here, here. So as you can see, five are five, right? Right.
Yes. If not,
Yeah.
we can also do like 1 out of 3 or.
Yeah, we can. Yeah, let's do five. Like it doesn't matter. It's the same at the end of the day, but but it's not like too much work anyways. Okay, 5 different addresses, each one with the same weight. You can put also like each one with one weight, but let's put 100. And the absolute count will tell you how many of those should approve a transaction. So if you want 3/5, you would do this, like 300. Now threshold also have other configuration. If you go here to the definitions in TypeScript, you have absolute count, which is the one we just saw, which is the name itself says it. Like if absolute count tells you like how much weight should vote for the proposal to pass, and in this case it's 303 people. But what happens if our members change constantly, or we add more members in the future? We don't want to be changing threshold also. So to do that, we can also use absolute percentage. And here would go percentage, like 100, 30, 50% of the people. Threshold quorum is more complex. I won't explain it right now, but yeah, it's very similar to absolute percentage. Quorum is basically quorum. It's the name says it. So it doesn't matter if you vote positively, you are also here in quorum. So if the quorum is reached, then the proposal goes through, or with the threshold, or is ditched and not executed. Let's go with this 3/5 and create a multisig. Create multisig. Okay, everything good. Yeah, I think it will go through. Yeah, there it is. Now, how you can see the members? You can see them. There's an event for everything. So we also have an event for when a multisig is created, and the multisig shows the members. Wasn't valid update admins. Wasn't create ICA controller. Wasn't create membership. Create membership. You go here and you can see the members. The 5 members. Now, if you want to query the members, well, you also have this the voting modules. The membership module. You must instantiate it and use the queries. Queries total web list members. There is. So here is like this list members, and that's it.
Thank you so much. I think it was pretty good. So if you do have like anything you would like to mention that you forgot to mention before, let me know. And for the audience, also like every Tuesday and every Thursday, there's at 6 p.m. UTC a developer call on the Archway Discord. I will display it in here. Done by Adrian, developer relation engineer at VLabs. So like if you have like anything left you would like to mention, please go ahead.
Yeah, get creative, guys. Read all the documentation. We on this workshop, I didn't put focus on the ICA because it's content, like it's a lot of content, and we have 2 workshops, so I prefer to split the information there. But even though that it is like that, try to read about it, like here in features. You can read about more here. Documentation, sorry. No, sorry. You can read more about it here. ICA controller. If you put this, you'll find this, the CW ICA controller. This is the tool we use to create ICA accounts. This is a smart contract. You will find all the information here. I'm not going to go deep on it, but try to read this, and if you get it and you feel confident on start building with ICA right away, great. You'll be more prepared for the next workshop. Also get creative with, for example, multisigs, sub-multisigs, signatures. Try to use signet voting. One idea, for example, is creating a multisig with a service that runs in the background and how you say it, sponsors every transaction in the multisig with every vote. Let's better every vote, because every transaction we don't have support yet. Also experiment with depositing funds on DeFi projects, or create. Also, if you go to the structure, you'll notice something. If you read carefully, you'll notice that the admins of the wallet are modifiable. What do I mean by this is that if you want to modify the voting module logic, you don't have to do it. Create your own voting module from scratch and put it as admin, and then you'll have a completely new features. Completely new features, because these admins are the ones that can send transactions to the wallet. So if you create your own voting module, put it as admin with a multisig proposal, then you'll have a new voting module that can send transactions to the wallet. So you can experiment a lot with that, because you can create automatic execution of stuff, for example, payments over time with a server or something. A voting module that only allows certain people with a stake in certain place to vote, or even a voting module that only allows contracts to execute proposals. Just put creative on that. You can modify a lot of things just by changing the admins.
All right, you have heard Rafael, so get creative, create your own voting module. So Rafael, thanks a lot for doing this workshop today. I think the audience learned a lot from you. Huge thank you to Rafael, Head of Development at Nomos. I think we all learned a lot about interchain accounts, Nomos multisigs, and super accounts. So yeah, looking forward to the next workshop. And if you have anything else you want to share, let me know.
No, that's it. Thanks, guys.
All right, then see you guys. Thanks a lot.